Got to give the people, get the people what they want. Back, I'm here in the room, holding it down. You can't see anything, but go ahead and write this down. Connections between polynomial equations and their graphs. This is like a recap of the stuff that you were supposed to get in class today. So I know, we're a little bit in a lot of different places, so this should help solidify. Don't forget to update your purple sheets with this information as well. We'll be checking it out in your notebooks. So, first of all, if you have x as a factor by itself, here is what I'm talking about. So if you have a polynomial that's like f of x equals x times x minus 6 times x plus 7. We're talking about when one of your factors is x. Well, what does that predict? This predicts that one root, in other words, one x-intercept, will be at 0, right? Because if I was going to find the root of this, I would need x to equal 0. So one of my roots is going to be at 0, right? So if I was to draw this, I don't know how, but I know at some point, one of those roots is going to be right here. It's going to cross the x-axis at 0, somehow, some way. Because x, this x right here, is a factor. So that's a big thing that you need to get. All right, so now they say, well, what if x minus, so now I'm here. I'm saying, well, what if x minus a is a factor? So similar example, if I have x times x minus 6 times x plus 9 squared, right? Here's a x minus a term, so x minus a being some number. Well, that predicts that one root will be at a. Or in this case, ooh, that's not how you spell case. In this case, 6, right? And I know this because, well, if I found the root, if I'm going to find the root of this, I need x minus 6 to equal a 0. What do I have to put in here to get an output of 0? I need x minus 6 to equal 0, so I need x to be 6. So that means I thought I was gonna erase this. So that means for you, in this particular, you heard that scream? That was great. But that means for you in this particular situation, right here, I know I'm gonna have an intercept at 0. And here, I know I'm also going to have an intercept at 6. And then something else is gonna happen, okay? Because I know that to find my root, I need x to be 6 for this to turn into a 0. Okay? Finally, this one says, well, what if x minus a squared is a factor? So again, I'm going to work with this same one. I have f of x equals x times x minus 6 times x plus 9 squared. So far, I have 3 roots. 1, 2, 3 roots. But actually, this is a double root because really this means x times x minus 6 times x plus 9 times x plus 9. So actually, we have 1, 2, 3, 4 roots. But these 2 roots are in the same place. Okay, so the way that I show that is that this predicts that this root will touch but not cross the x-axis So here's what this thing looks like. So let's see. I see my first root here is when x is 0. Boom. So x is 0. My second is where x is minus 6. So here's 6. And it does like this. Boom. Goes through there. Again, to get this root, I need x plus 9 to equal 0. Minus 9, x equals negative 9 is my root. So I got negative 9 over here. And I'm going to see that this thing is going to touch right here. And this counts as 2. Put this little thing in here. And this, ooh, that's terrible. This counts as 2 roots slash x intercepts, okay? So that's a key, noticing that that thing counts as 2 roots, x intercepts. So here's 1, here's 1, here's 2 of them. That makes 4 total roots, okay? So we gotta be clear with that. And that's gonna lead into the final part of this. The degree of an equation connects to the graph of the equation by what? Well, let's take this example. So if I have x times x minus 6 times x plus 9 squared, right? Really all I care about is my x terms and my largest x terms. So I could go x times x minus 6 times x plus 9 times x plus 9. How many times does x get multiplied by itself? Sooner or later, it's going to be 1, 2, 3, 4. So I'm going to end up with something times x to the 4th. This is a 4th degree polynomial. And if it is a 4th degree polynomial, this predicts that there are 4 roots, aka x intercepts. Okay? Just like we saw back over here. 1, 2, 3, and 4. Remember, when it just touches, it counts as 2. All right, those are the big takeaways that you were supposed to have from last class. Please use those. Please update those purple sheets, and we'll get into the next stuff tomorrow. Great job, you guys. Have a good weekend.